So good morning students. So previously we have discussed about the basic elements of optical fiber transmission link, then some basic optical laws and definition, that is reflection, refraction, numerical aperture, acceptance angle, then the basic principle, total internal reflection. Okay, so next we are going to see about the optical fiber modes and configuration. So under this optical fiber modes and configuration, we are going to discuss about the 5 topics. What are the 5 topics mean? Fiber types, rays and modes, step index fiber structure, ray optic representation and wave representation in dielectric slab waveguide. Okay, so we can see one by one. The first topic is fiber types. Okay, under this fiber types, so before discussing about fiber types, we want to study about the structure of the optical fiber. So if you see, this is the basic structure of optical fiber. So the first element is the core. Okay, it is a very important structure in optical fiber. So if you see the core, inside the core only the optical waves are transmitted based on the total internal reflection principle. Okay, so it is a single solid dielectric cylinder shaped structure. Okay, so the shape of the core region is cylindrical shape and it is a dielectric cylinder. Okay, and it has a radius A and the refractive index is N1. Okay, so the refractive index of core is N1. And next to the core region, that is the outer covering of core region, is the cladding region. Okay, so the core is surrounded by the same cladding region also. It is also solid dielectric substance. Okay, it has a refractive index N2. And the important condition we must remember here is N1 should be greater than N2. Always the refractive index of core should be greater than the refractive index of the cladding. Okay, so the innermost region is the core. So the core is surrounded by the cladding. Okay, and this cladding region has some advantages. What are the advantages means? See, it reduces the scattering loss. Okay, so when it reduces the scattering loss, automatically the discontinuity is also reduced. Okay, and it adds a mechanical strength to the fiber, and it also protecting the core. Okay, so these are some of the advantages of the cladding. Okay, and next, so these are some thing about the core, cladding and buffer coating. The outermost jacket of next to the cladding, the region is the buffer coating. Okay, buffer coating. So first region is core, so it is a very thin size. Okay, the core size of the core region is very thin. Okay, and this region only carrying the light from the transmitter to receiver, and the diameter of the core is about 5 micrometer to 100 micrometer. Okay, and the next region is the cladding. It is next to the region of the core. Okay, and it helps to keep the light within the core. Okay, it does not allow the light outside of the core. That is, it is a protecting layer of the core. Okay, and next region, that is the outermost region, is the buffer coating. It is a plastic coating. It protects the fiber. Overall, fiber is protected by this buffer coating. Okay, that is the outer jacket region. And next, we already studied about the working principle of the light, how the light is transmitted inside the fiber. It is based on the principle of total internal reflection. When the light travels from denser medium to rarer medium, what happens? And the main condition, angle of incidence. When the angle of incidence is greater than the critical angle, the rays will reflect it back and forth. Okay, in the same medium. So this principle is known as the total internal reflection. So it undergoes many reflections. Okay, it undergoes many reflections inside the fiber. This is the main principle in which the light travels inside the fiber. Okay, so next is the classification of optical fiber. The optical fiber are classified based on the 3 types. First one is based on the material. Okay, it is classified into 2 types. Then based on the modes, it is classified into 2 types. Then based on the refractive index profile, it is classified. So first of all, based on the material. Okay, based on the material, it is classified into plastic fiber as well as the glass fiber. Okay, normally the optical fibers are made up of the materials like silica and plastic. So it has some following properties, that is, diffraction, dispersion of optical energy also low. So this will be discussed in the second unit. Okay, second unit. So now you can see the types of the optical fiber. So mainly two types, one is glass and other one is the plastic type, or sometimes the core may be made up of plastic as well as the cladding is also made up of plastic. Sometimes the core may be made up of glass and the cladding will be made up of the plastic. Okay, so this fiber is known as the PCS fiber. Okay, and next the core may be made up of glass and cladding also made up of glass. So this is known as the SCS, silica clad silica. Okay, so these are some of the fiber which is made up of both plastic and the glass. Okay, so widely we are using plastic fiber, that is plastic cladding fiber structure we are using. Okay, so if you see the advantages and disadvantages, glass has the lowest loss. Okay, but plastic has highest loss. But what about the glass means it will be easily brittle. Okay, but plastic is more flexible. Okay, and more flexible, but plastic has high number of attenuation. The attenuation will be very high. Okay, the attenuation will be very high. And if you see the glass fiber, so the glass fiber are generally fabricated with metal oxide and the silica oxide. So normally the silica has the refractive index 1.45 at 850 nanometer. Okay, so these are some of the material which is included for the fabrication. That is, if the core is made up of silicon dioxide and cladding is made up of P2O3, okay, and SiO2. Similarly, these are some of the examples in which the materials is added for fabricating this glass fibers. Okay, and if you see the plastic fibers, and it is very low cost. Okay, the cost of the plastic fiber is low, but due to high refractive index, the difference between, that is the core and cladding materials, okay, it is the high numerical aperture. So if there is high numerical aperture, then the acceptance angles is also very high. Okay, and next, based on the mode. Okay, based on the mode, it is divided into two types. One is the single mode and multi-mode fiber. It is also known as monomode. Okay, single mode is also known as monomode. That is, what do you mean by single mode fiber? Means it allows the light in only one direction. Okay, in one direction. So on the basis of the mode, it is divided into single mode and multi mode. See here, first one is the single mode fiber. See here, it allows only one mode of propagation. Okay, one path, only one path is allowing inside the core region, and it has the core diameter, very small core diameter, because it allows only one light ray inside the core region. So the diameter of the core must be very small. So it is about a 5 micrometer, and the cladding diameter is very large. Okay, the cladding is about a 70 micrometers. See the diameter of the cladding, it is very large. Okay, and the difference between the refractive index of the core and the cladding is also very small. Okay, the difference is very small. And this is about the single mode fiber. And next is the multi-mode fiber. What do you mean by multi-mode fiber? It allows large number of modes. Okay, it allows large number of modes. See here, the different modes are directed in different colors. There is the pink is one light ray, then green is another color light ray, and blue, it is represented as another light ray. So it allowing large number of modes is traveling inside it, and the core diameter is about 40 micrometer and the cladding is about 70 micrometer. Okay, here the refractive index between core and cladding is very large. In single mode fiber, it is very less. Okay, and here see one disadvantage in multi-mode fiber, that is there will be some signal degradation. Okay, here there is some signal degradation in this multi-mode fiber, and it is not suitable for long distance communication. For long distance communication, mostly they will choose the single mode fiber. Okay, so next, on the basis of refractive index. Okay, on the basis of refractive index, it is divided into two types. On basis of refractive index, the optical fiber is divided into two types. One is step index optical fiber, and other one is the graded index optical fiber. Okay, step index and graded index optical fiber. So what what do you mean by, so see, it is the index profile. So if you see the index profile, so what do you mean by the index profile means it is the graphical representation of the refractive index. So how the there is the waves are traveling along the fiber. So it is the graphical representation of the refractive index across the fiber. So that is the index profile. Okay. So based on the index of refraction, it is divided into step index as well as the graded index. Okay. So first of all, we are going to see about the step index fiber. So what do you mean by step index fiber means here the refractive index of the core is uniform throughout and undergoes a step change at the cladding boundary. So if you see, so this is the so if you see here, the refractive index of the core is uniform. Okay, the refractive index of the core is uniform. Okay, and there is a step change. Okay, or sudden change. There is a sudden change in the cladding boundary. Okay, so there is a sudden change. Cladding boundary, if they touch near the cladding boundary, there will be a sudden change. Okay, there will be a sudden change in the cladding boundary. Can you understand? Okay, so there is a it undergoes a abrupt change or step change or sudden change at the cladding boundary. The core will be uniform. The refractive index of the core is uniform. Okay, and there is a sudden change at the cladding boundary. So this is known as the step index fiber. Okay, this is known as the step index fiber. And here next is the graded index fiber. If you see the graded index fiber, here the refractive index of the core is vary as a function of the radial distance, okay, from the center of the fiber. That is, there will be a smooth variation. The index of refraction will vary smoothly and continuously over the diameter of the core. Okay, there is no sudden change. They will move in a smoother manner. Okay, they vary as a function of the radial distance from the center of the fiber. They move smoothly and continuously over the diameter of the core. Okay, so it is known as the graded index fiber. Can you understand? Okay, so this is based on the configuration, that is index of refraction, and it is divided into step index fiber and the graded index fiber. Okay, if you see the step index fiber, the refractive index of the core and the cladding are constant. Okay, so here there is a sudden change in the cladding boundary. Graded index fiber, it has the non-uniform refractive index. Okay, the refractive index is non-uniform and it moves in a smooth and continuously over the diameter of the core. Okay, so based on the material, it is divided into plastic or glass, and based on the modes, it is divided into single mode and multimode fiber. Okay, based on the modes, it is divided into single mode and multimode fiber. If you see the single mode, the light follows a single path through the core. Okay, it follows the single path through the core, and if you see the advantages, it has no intermodal dispersion. But in multimode fiber, there is the intermodal dispersion, and the capacity of the information in single mode fiber is also very large. Okay, it carries more amount of information. And if you see the disadvantages, the launching of light in single mode fiber, okay, is very difficult. Okay, it is very difficult for the launching of light, and the fabrication is also very difficult in single mode fiber. And if you see the multimode fiber, here the light takes many paths through the core, and the number of paths in the optical fiber depends on the frequency of the light. Okay, it depends on the frequency of the light. So this is about the single mode and multimode fiber. And next is based on the refractive index, is divided into step index and graded index. So step index, there is a sudden change in the, that is the refractive index will be changed abrupt or suddenly in the cladding boundary. Okay, the refractive index is vary as a function of the radial distance. Okay, so in that is the graded index fiber. If you see the step index fiber, there is the index of refraction, that is the refractive index. Okay, the refractive index of the core is uniform throughout, and there is a small change at the cladding boundary. But in graded index fiber, it may vary as a function of the radial distance. Okay, so this is about the types. And next, coming under the optical fiber configuration, it is divided into three types. Okay, one is single mode step index fiber, next multimode step index fiber, then multimode graded it is a step index fiber. Then multimode step index fiber, more number of light rays are there, but it's a step index fiber. Okay, and then multimode graded index fiber. Okay, so what do you mean by single mode step index fiber? If you see the single mode fiber, nowadays these type of modes are used in telecommunication and networking. Okay, telecommunication and data networking, they are using this single mode step index fiber. Okay, so here you know the central core is smaller in diameter, and single mode fiber the core diameter is very small. Okay, and it has only one path, and here you can easily eliminate the intermodal dispersion because it has only one path. If there is more than one path means there will be some intermodal dispersion. Okay, so next is the multimode step index fiber. So if you see the multimode step index fiber, here the center core, that is the it is similar to a single mode step index, but here more number of paths is transmitting. Okay, so what about the center core? The diameter of the center core is somewhat large. Okay, but it is easy to manufacture. The center core diameter is about 50 to 200 micrometer. Okay, 50 to 200 micrometer. Okay, so here the light will be propagated in zigzag manner. There is many paths because it's a multimode fiber. And next is a multimode graded index fiber. If you see this multimode graded index fiber, here it has the non-uniform refractive index. So next is the multimode graded index fiber. So in multimode graded index fiber, it has the non-uniform refractive index. Okay, non-uniform refractive index. So it has several modes or paths because it is a multimode fiber. So it has several modes and paths. Okay, so here if you see there is a the index of refraction will vary continuously. Okay, because it is a graded index fiber. So the index of refraction will vary continuously, and the light rays are bent smoothly. And see here there is a smooth, and it converges repeatedly at each point of the cable. Okay, so this because of graded index fiber. Okay, so here the light rays near the edge of the core. Okay, edge of the core take a longer path but travel faster. Okay, take the edge, it takes the longer path and it travel faster. Why? Because the index of refraction is very low here. Okay, index of refraction is very low. And see here, if all the modes are arrive at one point simultaneously, means what happened? There will be dispersion. Okay, the result will be dispersion. So these fibers can easily couple the light. Okay, representation. So what about the ray optic representation? What is ray optics? It can be analyzed using either ray theory or mode theory. So if you see the ray theory, it indicates the direction of propagation of light. Okay, in which direction the light is propagating. Okay, so it is also known as the geometrical optic representation. Okay, so there are two types of rays. One is meridional ray and other one is the skew rays. Okay, there are two types of rays, meridional ray and skew rays. The meridional rays is divided into two types. One is bounded ray and other one is the unbounded ray. So what do you mean by meridional ray? So meridional rays are it passes through the fiber core axis. Okay, it passes through the fiber core axis. Then it does not move along. That is after the total internal reflection. That is from the total internal reflection is moving through the core boundary. Okay, so the meridional rays are passing through the fiber core. That is, it passing through the center axis of the fiber. Okay, and it is divided into two types. One is bounded ray and other one is the unbounded ray. So what do you mean by bounded ray? Means they will be trapped inside the core and propagate along the fiber. Unbounded rays means it refracted out of the fiber core. Okay, that is the unbound rays. And next is the skew rays, very important ray. That is, it not transmitted through the fiber axis. It does not transmit through the it does not transmitting through the fiber axis. It follows the helical path. Okay, it follows the helical path. So skew rays, it are reflected from the core cladding boundary and again it bounces off the outside the core, around the outside of the core. Okay, and these rays are more difficult to track. Okay, when it travels along the fiber, it is more difficult to track because it does not lie in a single plane. So it is more difficult. Okay, so skew rays will change the light, that is the acceptance light, that is the ability of the fiber. Okay, so the input, when the light input of the fiber is non-uniform, the skew rays have the so it has a smoothing effect. See here, there is a smoothing effect on the distribution of light. Okay, so now it has the uniform output. It gives the more uniform output. Okay, so the amount of smoothing is depends upon the amount of the reflection in skew rays. Okay, so from this, so it is the meridional is divided into two types, that is bounded and unbounded. So this, from the skew rays, you can, there is a derivation. I will derive it for you. So from